Hello everyone, we're back doing lab number 3 in which we'll be determining the uncertainty of measurements with standard glassware and equipment. Also looking to determine the accuracy of the measurements with standard glassware. For this experiment we'll be using our scale, and I have two here, one that came with the Carolina lab kit, and then I've also have a personal one that's made by Triton. It's the T3. This is my handy dandy scale that I use, but I do believe this one's a little bit more accurate than the little maybe it looks like something you can get at the dollar store for like $2. But for the purposes of this experiment, we'll be using the gray Carolina scale. First, what you want to grab is two different cups, and you're going to label one cup A and the other cup B, or 1 and 2, whatever you want to do. You'll also need both of your graduated cylinders and your 25 milliliter beaker and a permanent marker. So we'll go ahead and label our first cup. It would help if this permanent marker would write. Just give me 1 second. All right, we're back, and hopefully we have a permanent marker that works this time. All right, so we labeled this cup, cup 1, and we're going to label this cup 2. Now, whenever you turn on your scale, you want to make sure that you're doing it on a flat surface. Look at it and make sure it reads 0.00. Now, once you have the scale turned on, you don't want to lift it from any flat surfaces, as this can cause inaccuracies in the results. So first, you'll take your cup labeled cup 1, and you want to place it on your scale. Make sure it's zeroed out. If it doesn't, hit the tare button on the Carolina scale and go ahead and place it. For our first reading, we have 9.96 grams. So you want to go ahead and record that. Okay. Now we're going to take it off. Make sure it reads 0. And place the cup on it. Again, now we're going to do this a couple of times. As you see from the second try, we have a slight variation in the reading. Now I have 9.99 grams. Alright, we're going to take the cup off again. Let it restabilize to 0.00. And we're going to put the cup on here again. Alright, now it reads 9.96. We're going to take the cup off again. Let it restabilize. And put it back on the scale. Now for this reading, I get 9.98 grams. Take the cup off, let it restabilize, and place the cup on it a fifth and last time. and we have 9.98 grams. Okay, now we're going to take that cup off. Let's go ahead and turn off our scale, and we're going to turn it right back on. Now you don't need to turn off your scale. I just did that so the scale can restabilize. And we're going to take our cup number 2 and place it on the scale. Now this cup seems to weigh a little bit more. I have a reading of 10.05 grams. So we're going to go ahead and record that. Take the cup off. Let the scale restabilize and place the cup on there again. Record the reading. I have a 10.03 grams. Take the cup off. Put the cup back on there again. I have 10.04 grams. Take the cup off and place the cup on there again. Alright, we're going to take the cup off, let it restabilize one last time, and then we are going to put it back on there. And now I have a solid 10 grams. So it looks like each time I place the cup on there, it weighed just a little bit less. Okay. Now what we're going to do is determine the average mass of each cup using the data table that's been provided in our instructions. We're going to determine the average deviation of average of each cup. This is the uncertainty of your measurement with the balance. Now I'm going to go ahead and turn that off, and I'm going to see how accurate this scale that I previously purchased, how accurate this scale is. Since like I said, I stand behind this this scale here. Now it does read 0.0 grams. Now I get a reading of 9.9. Now this one will only give me 1 decimal point. So I can see why it would be a little bit more accurate since it actually rounds up to 1/10. So that's 9.9. We're going to take it off. It's 9.9 again. Take it off. And I have 9.9. So I turn that off. Now that wasn't part of our activity number 1, but I actually just wanted to try that to see how accurate that was. But as I said, it doesn't measure to the 100th as the Carolina scale would. So we're going to go back to the drawing board, determine the deviation from the average, and we'll be back for activity number 2. Hello everyone, we're back for activity number 2 of this uncertainty experiment. So what we're going to need for activity number 2 is we're still going to need our scale. We're going to need some water, the 25 milliliter beaker, the 10 milliliter graduated cylinder, and the 50 milliliter graduated cylinder. And we're also going to use the 250 milliliter beaker. Alright, now first we're going to start with our 10 milliliter graduated cylinder. Let's go ahead and turn on our scale. Make sure it stabilizes to 0.00 grams. If it doesn't, then make sure you hit the tare button. Now we're going to go ahead and take the graduated cylinder and place it on the scale. Now this weighs about 9.28 grams. So we'll go ahead and record that information. Okay. Alright, now let's go ahead and take that off the scale, and we're going to add 7 milliliters of water. Let's go ahead and take our water. Now I'm not going to use a syringe for measuring 7 milliliters of water, but I am going to use a graduated cylinder. Looks like I've added just a little bit too much. Well, actually, no. Alright guys, now we got 7 milliliters of water. Now we're going to go ahead and jot this down that we have 7 milliliters of water. Now what we're going to do is take the high and low volume, and we determine that by where you see the bottom of the meniscus, which at eye level it's 7 milliliters, and the top of the meniscus, so it's right at 7.1. Matter of fact, it's probably 7.01 milliliters. So if you determine your average volume of the water, you're going to take your high and low volume and the volume of the actual water to determine your average volume. So here my average volume is still going to be 7 milliliters of water. So I'm almost certain that this does contain exactly 7 milliliters of water. Now there's still the element that this graduated cylinder might not be as accurate as we would like it to be. So let's go ahead and turn it back. Looks like our scale turned off, so we're going to go ahead and turn that back on. Place our graduated cylinder on the scale. Alright, now that we have the weight of the graduated cylinder with the 7 milliliters of water, let's go ahead and record our weight. Alright guys, now what we're going to do is we're going to repeat the steps that we just did for one more trial. just to make sure everything is correct. So now that we've emptied out the water out of the graduated cylinder, we're going to go ahead and see if we can dry this a bit. Okay, now that we have our scale back on and at 0, let's go ahead and place graduated cylinder on the scale. And this time it appears to be a little bit lighter. I have 9.27 grams, which is just 0.01 of variation. Okay. Well, it actually changed. Now it's 9.28. So we'll leave it as is. The 9.27. Now let's go ahead and add our 7 milliliters of water. Alright guys, it looks like we have 7 milliliters of water. Right, so that's right at 7. I would probably again say that the high volume is probably going to be 7.01 milliliters, and on the low volume it's probably going to be right at 7 milliliters. So again, the low average being 7 milliliters. Now let's go ahead and turn our scale back on, and we're going to weigh out the mass of the glassware with the water. Hold on, let's make sure that this scale is zeroed out. So hit the tare button. And now we have 16.19 grams. Okay, so it's a slight difference from what we had in our first trial, this being our second trial. So let's move on to the 50 milliliter graduated cylinder. Alright, now we're going to take our 50 milliliter graduated cylinder, and we're going to go ahead and take the mass of the empty glassware. I have a reading of 29.19 grams. Now we're going to go ahead and add 24 milliliters of water to the graduated cylinder. Alright guys, now that we have 24 milliliters of water, let's just make sure that's what we see. Look like towards the high end, we may have 24.5, and towards the low end, we have 24 milliliters of water. So we'll go ahead and record our data again. Alright guys, now let's go ahead and turn our scale back on and place the 50 milliliter graduated cylinder containing the water on the scale and record the weight. Alright guys, I just had to make sure we had 52.73 grams here. So we're going to go ahead and empty out the contents, and we're going to repeat the steps starting with the empty graduated cylinder. So here we have 29.18, which again is a slight variation from the initial reading. We're going to take our 24 milliliters of water, Alright, now that we have our 24 milliliters of water, let's go ahead and place this back on the scale. Well, let's make sure that it's on. And we're going to take our measurement. Now we have 52.83, so we'll record that. A little bit different than what we got before. And let's turn that off, put the water back. And we're going to move on to the 25 milliliter flask. So we're going to take the weight, mass of the flask, record that. Looks like it's 27 it's 27 grams evenly. Now for this one, we're going to try to measure out 17 milliliters of water. So I'm going to recruit the help of our 10 milliliter graduated cylinder. Alright, so that's 10. Now we're going to look for 7 milliliters. Alright everyone, now that we have 17 milliliters of water, and since I used the 10 milliliter graduated cylinder to arrive pretty close to that 17 milliliter of water, let's go ahead and record the volume of the water, which is going to be 17 milliliters. I would say we're probably right at 17.5 milliliters for the high end and 16.8 for the milliliters milliliters for on the low volume. Now we're going to turn our scale and find out how much this flask with the water weighs. Alright, now I got a reading of 43.63 grams. Go ahead and take that off, empty the contents. Make sure we get all the water out. And let's find the mass of the flask. Alright, now this time I got, again, slight difference from what I got before. I got 26.98. Previously I had 27 grams. Now let's get our 17 milliliters of water back in. Alright everyone, now that I have 17 milliliters of water, let's go ahead and record that I probably could have had 17.5 milliliters on the high end, and maybe this time I'm 17 milliliters, since I have a feeling I went a little bit over the 17 milliliters of water. We're going to go ahead and turn our scale on and find out what the mass of the flask and the water weighs. So I'm getting a reading of 43.71, which is slightly higher than what I had before, and like I said, I had a feeling I had a little bit more than 17 milliliters of water. So we'll go ahead and empty that water out, and we're going to move on to using the 200 milliliter beaker. Alright, now we're back with the 250 milliliter beaker. Let's go ahead and find out what the mass of this empty glassware is. So on our initial reading we have 45.86 grams. And we're going to add 55 milliliters of water. And this actually measures, this reads by every 50. Okay, so every 10 milliliters of water. Right, let's see how close we can get to actually measuring out 55 milliliters of water. Alright, now I wasn't using the syringe to get the exact measurement, but just going off of eye level, I managed to get it right between the 50 milliliter reading and the 60 milliliter reading. So let's go ahead and record that the volume of the water is 55 milliliters. On the high volume, it's probably more like 56.5 milliliters, and on the low end, it's probably 56 milliliters. Okay, now let's turn back on our scale, place the beaker with the water to find its mass. So I'm getting a reading of 98.95. Now we're going to take that off, empty the contents, place the beaker back on the scale, to see what kind of reading we get. We're getting 45.84 grams. Or again, this time we're going to add 55 milliliters of the water. All right, again, I've managed to get it right between the 50 and the 60 milliliter reading. So this one I'm almost positive that I got right at 55 milliliters on the high end, and maybe 54.5 milliliters on the low end. So we're going to put this on the scale. That doesn't seem right. Let's tear this out. And I'm getting a reading of 199 grams. All right, let's go ahead and take that off. Empty the contents. Let's turn off our scale. Now, using our data, we're going to try to calculate the mass of the water in each piece of each glassware, and we're going to record our results in the mass table number 3. So once let's go back to the drawing board, find out our calculations, and see what kind of results we're getting. Okay. Now, as for activity number 3, we're going to go back and find out the room temperature. And for simplicity reasons, we're going to assume that the temperature of the water is the same temperature as the room. And we're going to use table 2 to record the density of the water at room temperature. And we're going to calculate the volume of the water for each of the activities that we did in activity number 2, and record it in our table data 3. So that would conclude all 3 activities. Now we're just going to go back and calculate them and write up our report.